My name is Tony Bates. I spent over 50 years conducting research into the effectiveness of technology for teaching in higher education, with a particular interest in video. What have I learnt from all that work? Well, in a nutshell, there are three most important conclusions. The first is that video can have very unique and valuable affordances or benefits that can really help your teaching. The second is that there's now a ton of material out there that you can draw on for free use over the internet in nearly every subject area and topic. And thirdly, and more disappointingly, is that instructors are generally not using video at all or very well. They're using it mainly for streaming lectures. There are good reasons why instructors don't use video more. Many think that it will be extra work. Many don't feel that they're qualified to make video programs. They're not video producers. And lastly, they're not quite sure what to use the video for, and that's probably the biggest barrier to greater use. So the aim of these videos is to encourage instructors to think how they could make effective use of video in their teaching. Now, there are two ways to go about this. The first is you can make your own videos, which is more challenging. But the second way is to make use of the many existing educational videos that are now available for free use over the internet. Now, using already made videos is, of course, the easiest, provided you can find the right video to fit your topic. However, nowadays, this shouldn't be a problem. In the last few years, there's been a huge growth in the number of educational videos over the internet that are available for free use. These are just one kind of open educational resources, or OER. Let's look at an example. I'm interested in finding a video on the topic of the difference between linear and exponential growth. So what I'm doing is just entering video of and then the topic. And you'll usually find a number of different examples. I've chosen this one made by Professor Matt Yedlin of the University of British Columbia. Let's see a clip from this.
Well, here we are again. We're going to do an experiment to illustrate the difference between linear growth and exponential growth. We're going to do a tapping exercise. It's going to be initiated by Amid. Amid's going to tap Peter on Peter's right shoulder, and then he will stand up. And then Peter will pass the tap down the row, and we'll see how long it takes for the tap to swing all the way through the rows, ending with Grant. I'll count 3, 2, 1. Grant's going to time. You'll be the point man. 3, 2, 1, go. How much time, Grant?
19 seconds.
Great. Sit down, everybody. Now, we're going to do it again. This time we're going to initiate it from the center. So, Sebastian, you're going to be the person who leads off. Camera ready? 3, 2, 1, go. Grant, how long?
3 seconds.
All right. Question for you. What happened in the first case in terms of people standing up? What happened? Yeah.
The rate of people standing up was constant.
The rate of people standing up was constant. It was about a half a second per person standing up, roughly. Now, we then did 2 taps. So 2, 4, 8, 16, 32, 64. 6 generations of tapping. At a half a second a tap, 6 times a half is 3. So we see the exponential growth effect. And that's what we see when there's a virus spreading. You can see, for example, if Sebastian was infected, this is a crude model of a virus, pass it on to the 2 neighbors and the 4 neighbors and the 8 neighbors. So it's a model for the spreading of a plague, an epidemic, and it's also a model, as we saw earlier, for a chain reaction and fission. Thanks all for participating.
I chose this example because it's an example of a very simple low-cost video involving a whole class and demonstrates a topic involving dynamic change. You could, of course, do this yourself in class without a video, but one advantage of using the video is that you can rehearse it and get it right, and more importantly, once you've recorded it, the students can access the video later and watch it as many times as they need. It's also a good example of an affordance of video. It's good for demonstrating examples of dynamic change in many different subject areas and topics. A very common topic that students often struggle with is the curve of normal distribution. Again, there are many videos available that vary in simplicity, complexity, and in length, depending on the amount of mathematics you want to include in the video. Here's one of the simpler videos that uses animation and graphics.
The average woman's height in the United States is 5 feet 5 inches tall. If you go out on the street and measure the height of the first 3 women that you find, the odds are very strong that it's not going to average 5 feet 5 inches. It'll average something else. You're going to probably get a wide variation. Like in this case, we have one woman that's close to 6 feet tall. But if you increase your sample size and start measuring the height of more women, the odds are that you'll end up with something that approaches a bell-shaped curve. Once you've sampled enough cases, you don't have to measure the height of every woman in the United States. You can use statistics to make predictions. Once you know your average and your standard deviation and your data fits within a bell-shaped curve, then you know that 68% of your cases will fall within 1 standard deviation of the mean, 95% of your cases will fall within 2 standard deviations of the mean, and 98% of the cases will fall within 3 standard deviations of the mean. A number of statistics assume normality, so it's important to know if your data resembles something like a bell-shaped curve before you use one of those statistics.
Again, this example illustrates a general use of video that applies to many topics and subject areas. Video is good for providing concrete examples of abstract principles through the use of graphics and animation. There is now so much choice in videos on the curve of normal distribution that instructors should be able to match a video or set of videos on the topic to fit both the context of the topic and also the abilities of your students and where they've got to in the course. Now you can use videos in class with your students or ask students to view the video on their own as preparation or follow-up. It's important though that students are asked to engage in some way with the video, such as responding to questions or explaining what they've seen. This has been one of the big problems with streamed lectures. There's not enough active learning on the part of the students. What about the extra work though? While an hour's work finding appropriate video on the internet or a day's work making your own video can save you many hours of teaching, students will be able to access the video many times and work through them, and you can provide activities for them. Thus, you're offloading the work from you to the student. The trick is to find ways in which video can explain concepts or demonstrate processes or provide student activities in a way that's difficult or impossible in the classroom. Sometimes, though, you may want to make or adapt something specific to your teaching topic or discipline area. We've therefore made 4 other videos that focus on instructors who made their own videos. We asked them why they made their video, how they made it, how much they use it in their teaching, and the impact it has had on their students' learning. And we also asked for any other benefits or drawbacks they encountered. I think you'll find these interviews particularly interesting to do things that would be very difficult in other ways, and really how it helps their student learning. Lastly, our final video looks at 3 different ways of making videos in a studio setting. That's the 7th video, which we have not made but has been made by UBC Studios. Our hope is that at least one of the videos in this series will inspire you to increase your use of video in your teaching so your students and you can benefit from it. In the next video in this series, we'll look at ways to teach that are uniquely suited to video. For more on the research that underlies these videos, and for more examples of the affordances, see Chapter 8.4 of Teaching in a Digital Age. This is a free, open access, online textbook for instructors.